Welcome back to the deep dive. Our world today, well, it really runs on this crucial split personality.
Oh, absolutely.
You have this need for an open identity so people can actually find you and interact with you. But then there's the absolute requirement for a secret identity.
The one that keeps your financial vault completely impenetrable.
Exactly. And in the volatile world of digital assets, mastering that distinction, it isn't just helpful, it's mandatory.
It's the bedrock.
Hmm.
I mean, it is the bedrock of decentralized security. When you engage with a network like Pi, you immediately run into that fundamental tension between public transparency and private security.
And that's what we're here for today.
It is. Today, we're undertaking a really focused deep dive. We're going into the source material from Pi Bazaar, specifically a security guide that's been crafted for users. It's all about understanding the absolute fundamentals of transacting safely.
So our mission for you, the listener, is to really unpack the public key. We need to know precisely what this crucial string of characters represents. Why do the sources so confidently assure you that you can publish it freely? And maybe most importantly, why, despite its public nature, careless handling can still lead to, well, financial disaster.
And by the end of this deep dive, you will have internalized not just the function of the public key as a digital address, but the complex cryptographic principle that makes it safe.
The secret sauce.
The secret sauce, yeah. The one-way mathematical guarantee that ensures your ultimate secret, your private passphrase, cannot be derived from it. This is the difference between, say, handing someone your business card and handing them the keys to your house.
That's a perfect distinction. Okay, let's unpack this crucial concept and start right at the beginning. Section 1. Decoding the public key, your digital postal address.
The guide kicks off with an analogy that I think it just instantly cuts through all the technical jargon.
Which is so helpful.
It is. They call the public key your postal address in the digital world. And it's a really easy concept to grasp.
Yeah.
I mean, if someone wants to send you a package, they need your address.
Simple as that.
If someone wants to send you pie, they need this key.
I do appreciate that analogy because it implies routing destination. But the digital equivalent, it has far more defined constraints than a street address. This isn't just any string of numbers and letters, is it?
Oh, not at all.
We're talking about highly specific characteristics that make it recognizable on the Pi network.
That's absolutely right. The structure is, it's fixed. It's mandatory. Unlike some variable identifiers you might see elsewhere, the public key on the Pi network is defined by the source material as a specific series of 56 characters.
56, not 55, not 57.
Exactly. That fixed length is a hard-coded constraint, and it immediately sets it apart from other data strings you might encounter.
56 characters. I mean, in cryptographic terms, that's long enough to ensure just astronomical uniqueness. It makes it virtually impossible to guess or randomly generate a valid key that already belongs to someone else.
Right. The sheer number of possibilities is just mind-boggling.
But what about the formatting? Does it have a signature, a marker of some kind?
It does, and this is another key identifier. The sources mandate that this key must start with the letter G.
Always a G.
Always. This starting character acts as an immediate identifier. It signifies that this specific 56-character string is intended for a Pi network wallet. It's really the network's way of ensuring the data being input is, in fact, an account identifier and not just, gibberish.
So it's a quick validation check right at the start.
It is. And that whole sequence uniquely identifies your wallet across the entire ecosystem.
To really drive home the specificity and the visual complexity of this key for you, we have to look at the full example the guide provides. I think seeing the string helps us understand the magnitude of the details we are discussing.
It really does.
Yeah.
It's one thing to say 56 characters, it's another to actually see it.
The example key is GCFHSO GXGXG Telaway BYXKQLF 4YH505 JT3Y XCYXBJZB.
And just look at that combination of capitalization, numbers, letters.
Yeah.
It's completely non-memorable.
Intentionally so.
Exactly how it's designed. Its complexity is really the first layer of its security. But the true security isn't its lengths or its starting letter. It's what you can't do with it.
Right. And that leads us to the crucial security distinction.
This is the core principle.
In a traditional information system, if I give you enough data, you can often reverse engineer the secret source. If I give you the hash, sometimes given enough computing power and time, you can find the original data.
Brute force it, yeah.
So why does the fundamental cryptographic design of the public key make it immune to this? this reverse calculation?
This is where we need to spend a little time clarifying the one-way street concept. It's so important.
Let's do it.
Okay, so the public key is derived from your private key, your seed phrase, using a mathematical function. It's a cryptographic hash function.
Okay.
Think of it like this. If you put a pane of glass through a very, very complex shredder, you can easily verify that the resulting pile of tiny shards came from that original pane of glass.
Right, you can match the material, the properties.
That's the creation of the public key from the private key.
So that makes sense. The easy direction is forward.
Yeah.
Private key creates the public key.
Exactly. Now, try to take that giant pile of complex glass shards, that's your public key, and reform it back into the original perfect pane of glass.
Impossible.
It's computationally impossible, and the guide explicitly relies on this fact. It states that the public key is specifically designed so that your seed phrase, passphrase, cannot be derived from it.
So if someone with a supercomputer, or a whole network of them, tried to reverse engineer my seed phrase from that 56-character public key, what are they actually facing? Are we talking about like decades, millennia?
We're talking about time frames that extend beyond the expected lifespan of the universe, at least with current computing technology.
Wow.
The security is based on this extreme mathematical difficulty. It's not that it's theoretically, in some abstract sense impossible. It's that the computational cost of reversing that hash is so immense that it is functionally and practically impossible for any malicious actor.
So it's a one-way door?
A one-way door. This irreversible derivation is why the public key is not considered sensitive information at all.
And that's the real guarantee the user needs to internalize? The danger isn't in someone seeing the public key. The danger is, and always will be, in sharing the private key.
Correct. The public key is simply necessary for the network to route assets to you and to verify that you are who you claim to be, without ever revealing the secret information that actually locks up the assets.
It's perfectly aligned with that real-world security comparison the source material uses.
The phone number analogy.
Exactly. Sharing your public key is like sharing your phone number. It's necessary for communication and transactions, but it doesn't grant access to your private data or, your financial vault.
It's the perfect non-secret. It confirms identity without compromising security.
Okay. That really establishes what the key is. Now let's move seamlessly into Section 2, which covers its functional roles, the two jobs of the public key. Why is this specific 56-character string so essential to the day-to-day operation of the Pi network?
It's essential because it carries out these dual functions that are crucial for every single transaction. It's not just an address, it's also, in a way, an authentication tool.
Okay, let's start with the address role. Job 1. Receiving Pi. That seems straightforward, but let's elaborate on its importance as the destination.
Functionally, it is the sole destination address. Whether it's another user, a service, or an application that wants to send Pi to your account, they must have this public key.
No other way to do it.
None. If the key is entered, the Pi is routed. If the key is absent or incorrect, the transaction just can't happen, or goes into the void, or worse, to the wrong recipient.
Right, which we'll get to. So it's the immutable target. If the address is right, the network knows exactly where to deposit the asset.
Correct.
But as you mentioned, the key has an active role, which seems a bit counterintuitive since we know the private key is what's needed to actually authorize an outgoing transfer. So that's Job 2, transaction verification. How does the public key verify ownership when I initiate a send without ever seeing the private key?
This is the truly fascinating part of asymmetric cryptography, and it really demands a deeper explanation.
Let's dive in.
Okay. When you decide to send Pi, you use your private key, your seed phrase, to create something called a digital signature for that specific transaction.
A signature.
And this signature is unique to the message, so the transaction details, and it's unique to your private key.
Okay, so the private key isn't sent across the network. It stays locked away, safe on your device. It stamps the transaction with a unique one-time proof of origin.
Precisely. Now, here is where the public key steps in as the validator. The network received the transaction, the details like who to pay and how much, and this digital signature. It then uses your public key to verify that signature.
Okay, so the public key is the checker.
It is. The public key checks two things at the same time. One, that the signature was generated by the corresponding private key, the one that generated this public key in the first place.
Got it.
And two, that the transaction details haven't been tampered with since the signing happened.
It's like having a master cipher. The private key scrambles the message in a very unique way, and the public key has the exact non-reversible mathematical inverse that proves only the true owner could have done the scrambling.
That's a great way to put it. If the public key can successfully decrypt and validate that signature, the network is assured that the transaction is legitimate. It's non-repudiable, meaning the owner can't deny it later.
Ah, right.
And it proves that the asset is being sent by its true and current owner. This is the entire engine of security for the network. The public key validates the authority of the private key without ever exposing it.
That structural security is clearly sound, but the source material also gives us a little peek behind the curtain at future capabilities, suggesting that the current system of key management might be expanding.
It does.
They mentioned that users will eventually be able to create more public keys on their Pi wallet.
And this is a significant indicator of planned complexity. In more advanced crypto use, you might want different keys for different purposes.
Like what?
Well, perhaps one for personal transactions with friends, another for commerce, and maybe a third for interacting with a specific D-app. It improves your privacy and security by compartmentalizing risk.
So if one key is exposed or compromised in some context,
It doesn't affect all your funds. They're separated.
that makes a lot of sense. However, the sources immediately introduce a current limitation that kind of tempers that future vision. Right now, key creation appears to be quite restricted.
That's the crucial caveat, and it really highlights the current, still developing nature of the mainnet. Currently, the source confirms that only applications within the Pi ecosystem are able to create multiple keys.
So not the user directly.
Not directly. This means the core functionality of generating new security identifiers is managed, regulated, or you could say centralized by the approved ecosystem apps.
That's a really significant detail for the learner. It tells us that while the underlying cryptography is decentralized and trustless, the application layer, the layer users interact with every day, is currently controlled and curated by the core project structure.
Right, and that's likely for stability and security reasons in these early phases.
It creates an interesting dynamic, though. The user has ultimate sovereignty over their seed phrase, their master key, but the tools they use to generate diversification and compartmentalization, those multiple public keys, are currently subject to application governance.
It's a pragmatic approach to scaling, for sure, but it's important for users to understand that key management isn't a free-for-all just yet.
Understood. Okay, so we've defined the key and explored its cryptographic role. Now we move into section 3, which is maybe the most critical part for practical safety. Handling the key, the simple rules for safety.
This section translates all that deep cryptographic security into simple, actionable steps. It's where the rubber meets the road, It separates the technical knowledge from day-to-day user behavior.
And Rule A is all about disclosure and publishing, which is a direct consequence of that non-reversible design we spent so long discussing.
The instruction here is completely unambiguous. You can publish your public key without any worries.
Without any worries.
None. You can post it on a forum, share it on a receipt, broadcast it widely. The source explicitly reiterates that safety comes from its non-derivable nature. This is the green light for commerce and transparency.
That assurance is powerful. But then Rule B immediately introduces the single greatest point of failure, which is the user themselves. This is the warning about copying and checking.
And this is the rule that demands the most vigilance. This is where we need to dwell on that crypto horror story you mentioned earlier, because the stakes here are profound.
We're dealing with 56 characters. That's too long to read aloud or manually verify without specialized software. So what happens if a user copies that key? Maybe they miss a character at the end, or they accidentally swap a lowercase l for an uppercase a during manual transcription?
Well, the consequences are binary and often catastrophic.
Yep.
The best case scenario is that the one wrong letter renders the key mathematically invalid.
So it just fails.
The transaction just fails, and the assets are returned to the sender. It's annoying, but you're safe.
Okay. And the worst case scenario?
The worst case scenario is that the wrong letter or character results in a completely different but valid public key.
Oh, no.
And that means the network processes the transaction perfectly, routing the Pi not to you, but to some unsuspecting random recipient somewhere out there. The assets will end up somewhere else.
And because decentralized ledger transactions are immutable, they cannot be reversed, canceled, or refunded. That Pi is just gone.
Gone forever.
You've essentially gifted your assets to a random person because of a typo.
Precisely. The system didn't fail, the human input failed. And this underscores a foundational reality in cryptocurrency. The security systems can be perfect, but the margin for human error is zero.
The source is absolutely right to stress this. If you are dealing with high-value items, like the jewelry we'll talk about later, a single typo represents a permanent, unrecoverable loss.
It does, which makes the use of copy-paste functions and visual verification tools mandatory, not optional. Manual transcription is a suicide here.
Absolutely.
Agreed. The burden of correctness is entirely on the user, and the lack of a centralized undo button means that double-checking those 56 characters is the single most valuable minute you can spend in any transaction.
Finally, Rule C covers general security practice in a growing digital marketplace, trusted sources.
Right. Rule C advises users to only share their public key with trusted people, applications, and services.
Now, why is that? If sharing the key doesn't expose my funds, what's the risk?
That's a great question. So while sharing the key can't lead to your funds being stolen directly, sharing it with a malicious application could lead to other types of compromise.
Like what, for instance?
Well, they could use it for advanced phishing attacks. They could send you fake transaction requests, hoping to trick you into signing them with your private key. Or, in the context of commerce, they could use your public identity to scam other people.
Ah, so they could create a false paper trail.
Exactly. A false trail that links fraudulent activity back to your Pi address, harming your reputation and potentially flagging your account for suspicious activity within the community.
So it's about protecting your digital reputation and reducing your surface area for social engineering, even if the assets themselves are technically safe.
Exactly. The overall guarantee holds true. If you follow these simple rules, your Pi will be safe. But that safety is conditional on user diligence, especially concerning Rule B.
And that transition takes us perfectly into Section 4, moving from personal diligence to community vigilance, security and fraud detection. As the ecosystem matures and commerce explodes, bad actors inevitably follow.
This is where security really has to become a community effort. The guide recognizes that users need a mechanism to determine if the other party is acting in a way that is inconsistent with the network, which is a polite way of saying, is this person a scammer?
Right, identifying scams, fraudulent listings, or known bad actors.
And the Pi community is stepping up to provide these evolving tools. So what kind of resources are being developed for verification?
The source material confirms that the community is actively building these resources out, specifically mentioning databases, forums, and tools designed to help users with verification.
It makes sense. In a decentralized environment, this collective vetting process, where users report and track known scam keys, is essential because there's no central bank you can call for help.
It sounds like a decentralized neighborhood watch, leveraging the community's shared knowledge to keep everyone safe. But this is where we hit what I consider the most critical, high-stakes piece of information in the entire source material. A massive red flag for any user concerned with rigorous technical security.
Yes, the source gives an example of a specific fraud analysis tool, one from PiTrade that provides quick analysis, but the associated critical warning immediately follows.
And this is so important.
The tool does not use SSL, and therefore the browser warns before accessing the page.
Okay, let's stop and define that, because for our listener, this might sound like technical noise, but it is an immediate catastrophic risk. What is SSL, and what does it mean when a site doesn't use it?
SSL, or Secure Sockets Layer. It's now typically called TLS, Transport Layer Security. It's the cryptographic protocol that encrypts the connection between your web browser and the server you are visiting.
The little padlock in the address bar.
That's the one. When a browser shows a green padlock, or HTTPS, it guarantees two vital things. One, that the communication is private, it's encrypted. And two, that the server you are talking to is authenticated, meaning it is who it says it is.
So if the browser gives you a warning, a big red screen, a broken padlock, a severe alert, it is screaming at you that neither of those two guarantees are in place. The connection is unsecured.
Precisely. Bypassing that warning means that any data you enter or any data the site sends back to you is sent in plain text. It is vulnerable to interception via what's called a man-in-the-middle attack.
So an attacker on the same Wi-Fi network, say, at a coffee shop or an airport,
Could potentially read everything you transmit to or receive from that non-SSL site.
And here is the profound paradox. The user is being asked to intentionally compromise their connection security, to open themselves up to potential MITM attacks in order to verify the security of a third party they plan to transact with.
It's a genuine security catch-22. To check if an address is a scam, you have to visit a site that might allow an outside actor to surveil your entire browsing session or even inject malicious code. It forces the user to choose between the risk of transaction fraud and the risk of network interception.
This suggests that while the community is rapidly building tools, which is great, the quality control and the adherence to modern security standards for those tools are lagging far, far behind.
It does.
So how should a learner approach this? Should they ever bypass a major browser warning like that?
As a rule, bypassing an SSL/TLS warning is extremely risky and should be avoided, especially in a financial context. If you are entering your public key or any details about a suspicious counterparty onto a site that isn't encrypted, you are essentially signaling to any potential eavesdropper exactly what you are doing and what keys you are interacting with.
And what if that site were malicious itself? What if it was a bad actor disguised as a scam checker?
Well, then it could harvest the public keys of the people you are checking, giving the fraudster a better database for future targeting. It's a huge risk.
It really is.
The existence of this warning requires the user to perform a critical assessment. Is the potential information I might gain from this non-SSL tool worth the immediate security risk I'm incurring just by accessing it? This highlights the difference between robust cryptographic security and, well, weak infrastructural security in this nascent ecosystem.
That's a fantastic point that you, the listener, must weigh. It's crucial we note the specific URLs listed for those engaging in verification and reporting, keeping this context in mind.
The two primary links listed for analysis and reporting are https.pinetwork.tradecheck-scam and https.masascan.io report-scam. And we have to reiterate extreme caution when interacting with the first one, given that explicit SSL disclaimer.
The PiScan link, though, it appears to be secure. It focuses on reporting, which is a better, lower-risk mechanism for users anyway.
A much better mechanism.
This entire section reinforces the idea that even with perfect private key security, the environment you operate in and the tools you use can introduce huge non-cryptographic vulnerabilities.
Absolutely.
And that brings us to Section 5, where we put this security advice into its full context, understanding the landscape of the Pi network.
When we read a security guide, we really need to understand the platform it's serving. And this guide originates from PiBazar.eu, which the source identifies as the first community bazaar in Europe designed specifically for peer-to-peer commerce using Pi.
So this confirms the security guide isn't theoretical. It's designed for real-world exchange. And the platform positions Pi as highly accessible, describing it as the first digital currency that you can mine on your phone.
And that positioning targets a broad, non-technical audience.
It does. And that mass market ambition is borne out by the stunning array of commerce categories they list. This is not a niche marketplace for digital art. They're aiming for full-spectrum retail.
It's an everything store. They list automotive, house garden sports, children's toys, electronics, PC mobiles, mobile accessories, cosmetics, drugstore, services work, jewelry, watches, valuables, clothing.
And it gets more serious. Alcohol, cigarettes, 18-plus key Lara, and other.
That list is extraordinary in its breadth. When you see categories like automotive, jewelry, watches, valuables, and alcohol, cigarettes 18+0, it shows an ambition to handle high-value and regulated goods. This changes the risk profile entirely.
It dramatically raises the stakes for transaction security. I mean, if I'm sending Pi to someone for a mobile accessory, the risk of loss is manageable. If I am transferring a substantial amount of Pi for a watch or a vehicle,
the catastrophic nature of a single character typo rule B becomes exponentially more serious. The loss is real and significant.
And the listing of regulated goods like alcohol and cigarettes products with age restrictions and often strict taxation, that suggests that the ecosystem is confronting the challenges of traditional commerce law within a decentralized, pseudonymous network.
That's a huge point. It's not just about P2P transfers anymore. It's about compliance and high-value disputes.
Exactly. This is why the security guide is so important. When you mix high-value physical goods with immutable digital currency transactions, you are introducing traditional fraud risks like non-delivery or misrepresentation of goods on top of the digital risks we've already discussed.
The user has to master both sets of risks simultaneously.
Now let's look forward. The More Articles section acts as a kind of forward-looking statement, projecting significant future milestones, all time-stamped with that late-stage update of Jan 4, 2026. This is a deliberate projection of what the developers anticipate.
And the key takeaway here is the theme for the following year, 2025, is the year of open network and ecosystem development.
That directly addresses the centralization we noted earlier regarding key creation.
It does. This projection implies a significant shift is planned, a move to full operational openness, which would expose the network to a much wider and less controlled global community.
And they actively place this expansion in a global context, referencing the 2025 overview, Pi Network in the context of global cryptocurrency markets. They are not content to be an isolated mobile mining app.
No, they are setting expectations to compete with established major crypto players. Furthermore, their focus on commerce goals is very, very strong. They project that the financial engine revs up as holiday commerce breaks records for Christmas 2025.
That's aspirational language. It's designed to instill confidence in Pi's utility as a medium of exchange, signaling that the network's future value lies in its transactional volume, not just its speculative price.
And the relentless commitment to community building is evident in the constant reference to the Pi Network Hackathon 2025 results and analysis. This shows a healthy feedback loop between the core team and external developers, which is vital for building out those necessary security and utility tools we were talking about.
But nestled amongst all this ambition, there is a piece of information that serves as a profound, self-aware cautionary tale, one that users absolutely must process.
This is a big one. The guide flags a related article titled The Pi Network and $314,159 value, the biggest hoax in the project's history.
That is a staggering disclosure to embed in a document that's promoting commerce. By calling out the biggest hoax about an unrealistic valuation, the source material forces the learner to recognize that the ecosystem has been plagued by extreme hype and misinformation.
It creates a fascinating internal tension, doesn't it? The platform is simultaneously marketing massive commercial success, jewelry, cars, holiday records, while warning that the most pervasive narrative around its theoretical value is a complete fabrication.
It's a clear signal that the community has a problem with speculative fervor overriding practical utility.
And the learner has to ask, if the management acknowledges this massive internal falsehood, how much of the other aspirational language is grounded in reality, and how much is just marketing necessary to combat that hoax narrative?
That paradox is only heightened by the mandatory critical disclaimers provided in the source material. These are not fine print. They are the governing reality of participating in this market, and we must relay them fully.
Absolutely. Let's start with a severe investment risk warning.
The guide is unequivocal. The content reflects personal opinions and current market conditions. They state that investing in cryptocurrencies carries a high level of risk and is subject to significant price fluctuations.
And critically, they state this risk could potentially lead to financial loss. This is not a subtle warning. It's an explicit statement about the possibility of ruin.
And that possibility of financial loss directly contradicts the aggressive commerce ambition. I'm encouraged to trade high-value goods, but told that the currency itself is subject to extreme risky fluctuations.
That tension must be noted by the user. And next, the no advice warning places all responsibility squarely on the user's shoulders.
Right. The guide states the website is for informational purposes only and does not constitute investment advice. Users are urged to do their own research, the classic DYOR, and make decisions with caution.
This is the project legally distancing itself from any user losses.
And finally, the standard but necessary advertising note, which acknowledges potential sponsored content and affiliate links. This simply reminds the user that while the information is provided, the platform itself is monetized, existing within a commercial framework.
And that timestamp Jan 4, 2026 lends a lot of weight to these warnings. Even with 2 years of future development projected, the warnings about high risk, price fluctuations, and the acknowledged history of hoaxes remain absolute. The user is entering a complex, high-stakes environment where technical security is guaranteed by cryptography, but financial safety is explicitly not guaranteed by the platform.
Okay, that brings us to the end of our deep dive. Let's synthesize the core findings we've uncovered about the Pi Network's public key security.
Let's do it.
We established that your public key is a unique 56-character digital address. It's safe to share because of that irreversible one-way mathematical function that prevents anyone from deriving your private passphrase from it.
Structurally, it's sound.
Absolutely.
We detailed the dual roles of that key, acting as the secure destination for receiving Pi and serving as the critical validation mechanism that verifies a transaction's signature, confirming ownership without ever exposing the private key used to sign the transfer.
And we learned that the simple rules for safety are, well, profoundly counterintuitive. You can publish the key freely, but you must exercise zero tolerance for error when copying it.
Because one wrong character results in irreversible financial loss.
Exactly. And most critically, we highlighted the community security paradox in the wider ecosystem. The pressure on users to bypass strict technical security warnings, like non-SSL browsers, just to access third-party tools that are meant to prevent fraud.
Forcing users to trade one type of risk for another? It's a difficult position.
It is. And we wrapped up by placing this guide in its ambitious context. A platform encouraging the high-value commerce of jewelry, vehicles, and regulated goods, yet one that simultaneously demands extreme personal caution and explicitly warns the user about the project's own history with massive financial hoaxes.
Which leaves us with this final provocative thought for you, the listener, to consider. Given the absolute confidence the ecosystem places in its foundational cryptographic security, the safety of the public key, how do you reconcile that technical certainty with the explicit, non-cryptographic risks introduced by the ecosystem's commercial ambition?
Hmm.
If the guide mandates trading in high-value, high-risk items while demanding extreme caution and acknowledging a history of massive financial deception, does this tension indicate a fundamental misalignment between the project's goal of mass adoption and the reality of a volatile, unregulated, and self-admittedly risky market?
So what are you truly being asked to trust?
Exactly. Think about what you are truly being asked to trust.